Tekla Structures Masonry Tools, Lesson 1, The Masonry Tools, Part 1. Topics in Lesson 1 include providing an overview of the shape catalog, a discussion on how Tekla applies masonry units, specifically focusing on profile versus shape, and demonstrating the concrete masonry unit tool by constructing a basic wall. As discussed in the introduction, the masonry tools utilize shapes and place items to create units, as well as walls and other masonry structures. In Tekla Structures, shapes can be found in the Shape Catalog. Users can access the Shape Catalog at any time through the File menu. Simply go to File, Catalogs, and then Shape Catalog. The Shape Catalog is a dialog box that contains information on shapes. It is used for viewing shape properties and for importing and exporting shapes. The catalog includes default shapes, for example, default, and concrete_default, which is an actual masonry unit. The shapes you download from the Tekla warehouse, such as those provided by the masonry tools themselves or even formwork systems, are also displayed in the Shape Catalog. The shapes listed in the Shape Catalog are stored in the current model folder, and there are two files for each shape. One, a .xml file stored in the Shapes subfolder, and one .tez or XML file in the Shapes Geometry subfolder. The shapes that are used for the items in the model are automatically copied to these folders in your model folder. Additionally, you can import and export shapes through the Shape Catalog using the respective buttons located down at the bottom of the dialog box. You can import the following shape types. If you have any three-dimensional masonry units in these formats, they can be brought directly into Tekla Structures via the Shape Catalog and used then with the masonry tools. When exporting shapes for sharing or placing on the warehouse, they are saved in the destination folder that you specify as a .tsc file. If there are shapes that you would like to have available in the Shape Catalog dialog box for all new models that are created in your project or company, you can copy the corresponding .tez and XML files to the correct subfolders, shapes, and shape geometries that are located under the profile folder in your project or firm folder. This specifically means additional shapes created by the user or brought in from other sources aside from the masonry tools. Before we move on to our next lessons, we should take a moment to understand how masonry units are applied within Tekla Structures. Masonry units are created as parts, or a piece. Parts are a building object that is a basic element of a model, and that can be modeled and detailed further. The geometry of a part can be defined in two different ways. We can use a profile, which is often used to create columns and beams, panels, slabs, and many other types of objects. And we can also use a shape, which is different from a profile and is used usually in item creation. Let's talk a little bit more about what profiles are and then what shapes are. Profiles is a part property that specifies the cross-section of the whole length of the part. Now, profiles are dynamic and they can have more than one cross-section, and the separate cross-sections can have different geometrical forms and dimensions. The part cross-sections are extruded to create the length of the part or your 3D object, and profiles can be created natively in Tekla Structures. Here is an example of a profile being extruded along 2 points. We have a W8 by 48 extruded 7 feet to create a beam. You can see here in the profile catalog that there are various properties and dimensions associated with that W member. Profiles do provide the largest amount of flexibility within Tekla Structures. However, it is important to note that their ability to vary in length does allow for greater user error in creating masonry units specifically. Now, that isn't to say they shouldn't be used for masonry. They should be used where it's appropriate, for lintels and sills, or even some cast-in-place elements that associate with your masonry units. But the majority of units should be utilizing shapes via items. A shape is a property that specifies its geometry in space. Shapes are used to define items. Shapes are static. They can be created natively in Tekla as well as profiles, but they can also be defined from other modeling software such as SketchUp. So the shape catalog, which is different from the profile catalog, accepts multiple file types such as .skp from SketchUp, DWG, GGN, IGES, and many, many more. So for those of you who have a 3D library of some masonry shapes, actually may be able to utilize them in Tekla Structures as an item. Now, to compare the item to the profile that we had before, this image here shows a much more complex object, but with a simplified dialog box. The shape catalog simply lists the shape and whether it is solid or non-solid. This usually means if it's watertight or not in its geometry. You can see the object itself has several different parts, although it is one entire object. If you were to model this with profiles, each one of those members would need to be modeled separately. But as an item, it just is as it's shown and is consistent. Shapes require less system resources to render in Tekla Structures than profiles. So this makes them ideal to use in applications where large quantities of them are required, such as masonry units, formwork, hardware, and many, many others. Tekla Structures masonry tools utilize shapes via items, and it provides the best possible performance of large quantities of actual 3D objects. It allows for consistent flexibility in shape definitions without the risk of modeling errors or making something slightly wrong dimensionally. And as mentioned before, it allows users to utilize their existing 3D library, if they do have one, with the current masonry tools. Okay, let's go ahead and take a look at how this practically applies to masonry. I think first let's take a look at what a profile does with the beam tool. So let's go up to our concrete ribbon and select the beam tool. And then we're going to go over to the properties pane on the right hand side and we're going to change the profile. We'll go ahead and select concrete masonry units drop down and then CMU blocks, and we'll choose the standard 8-inch unit. We're going to place the beam vertically and we're going to go up 7 5/8 inches. I'm just going to key that in. And then you can see we have a masonry unit here. Now, if we select this block and then with direct modification turned on, you can see I have the height there, and I can actually pull this or change that dimension on the fly, which is usually a great benefit. However, in this case, we want our unit standardized, so a user could accidentally modify the blocks without even realizing it and only catch it later. Another thing with profiles is if I wanted to change this profile and go to a different, say like a bond beam, let's go ahead and choose the bond beams and 8 inch as well, and then hit apply. And we can see that the profile is actually in the incorrect direction. We're going to have to move the grips down to kind of right that. And you'll see here that it takes me a couple of tries to make sure it gets snapped to vertically there. So it's a little cumbersome to go ahead and switch blocks on the fly, which is something we're definitely going to want to have the ability to. And then we have to specify the length. So let's take a look now what it would be to use item. So go back to the concrete ribbon and select item, and we'll use just the default here, and we'll pick 2 points. We can go any distance we want, 6, 9 inches, something like that. And there we go. And here we have a standard unit. Now you can see if I grab this grip and then move it out further than the block's length, the block does not change. If I do change its elevation though, however, it will provide a pitch to the block if we need it. So we are able to control it that way. But if we go back and change the profile in the shape catalog, we can kind of narrow our selection down to just CMU units by searching. And let's go ahead and choose an 8x8x16 standard block. Actually, no, yep, there we go. And then hit modify. And you can see there, it's in the same direction. But let's try that with the bond beam like we did with the profile. So let's just scroll down and we can choose the bond beam and hit OK and hit modify. And the block is actually still in its correct orientation. We can do this and repeat this again, however we need to. So it's pretty easy, as you can see, to kind of utilize items in the pre-existing shapes. No matter what we do with our grips or how we model them, they're going to be in the orientation dictated by the shape. It's easy to kind of change the position. We can rotate around the insertion points or the block in and of itself if we do need to manipulate that kind of stuff. But it's a lot easier to maintain and manage these items, and it's a lot less on our system resources. So although this example is pretty basic, it does prove the points on why there's some efficiency and benefits to using items and shapes for our masonry units. And as we get into the masonry tools themselves, you'll be able to see the benefits even further. For the last part of this lesson, we're going to take a look at the CMU tool. This is the tool that places individual single blocks for us. And the reason we're looking at this tool as opposed to, say, using the item tool found in the concrete ribbon is that it allows us to go ahead and tag our blocks with certain information, similar to the way the CMU wall tool does as well. So it helps us keep consistent. So what we're going to want to do then, before we get started, is condense our work area. So we'll go up to the view ribbon, and then we're going to select the work area drop down, and then choose using 2 points. And we'll just use a rectangle to go ahead and encapsulate the left-hand grid. So from here, we'll go over to the applications and components, and we're going to place a single block using the CMU tool. Remember, it's found in concrete and then CMU tools in the drop-down there. We'll just click on the tool once, pick an insertion point at our A and 1 grid intersection, and then key in our distance of 15 5/8 to provide the second point. And here we have our block. Now the tool has a dialog box associated with it, and we can get to it by one of 2 ways. We can double click the icon for CMU in the Applications and Components side pane, or after placing a block we can simply double click on that, and it'll load up the dialog with the applied properties. So as you can see here, we have several fields that we can apply to this block. If we select Objects within Components, and then pull up the Properties pane and select the block that we just placed, we can see how these fields in the dialog box correspond with the attributes for the item itself. Shape is to shape, material is to material, class, name, and we have the ability through the dialog box to also access the material and the shape catalogs to change those properties on the fly. So we can see this correlation and then go ahead and populate that information intelligently and with purpose. Now, before proceeding forward, let's go ahead and change our selection type back to Selecting Components in the bottom toolbar. Pressing the Select button will allow us to bring up the shape catalog that'll instantly populate into the dialog box in and of itself. Let's go ahead and choose a bond beam, and then we can hit Modify, and you'll see that the shape updates there. And it's the same thing for material. Change the class. We can go ahead and provide a height. I'll put in 7 5/8 inch. Now, design name and design group mark, these are fields in which we can tag our blocks with, and the CMU wall tool also has these. So I'll use BB as a shorthand for bond beam for the design name, and CMU just as a general identifier for the group. I'm going to save this up at the top and call it TS for Tekla Structures _CMU _bond _full. And once I hit the Save As, you can see it'll be here in the drop-down menu for me to load, and I can switch between some of the presets and then change quickly on the fly. It's really a great practice to go ahead and create safe settings of standard blocks or wall configurations with these tools so that you are able to load them on the fly. You can even store these settings in a company firm folder so you can use them on every project. Now, to proceed forward, let's go ahead and populate the dialog box as shown on screen and modify our CMU block. And for good measure, let's go ahead and save these dialog settings as well. Now that we've used the dialog to apply the properties directly to our block, let's go ahead and hit OK and close the dialog box. From here, what we're going to do is copy this and form a masonry wall manually. This is what the CMU wall tool does on its own, and we can do this by selecting the block, right-clicking, and then hitting Copy Special, then Linear. In the Copy Linear dialog box, we're going to go ahead and populate 16 in the X field, and we're going to give it a number of copies of 15. This will go ahead and give us a course of 16 blocks total, and we can go up to the Edit ribbon and drop down Measure and select Distance, and we can actually select and verify our gap spacing. When working with walls of any kind, it's important to note that one of the best practices is to actually work in a vertical plane or an elevated view. This makes snapping and just moving around a lot easier, and you stay flush and plane with the actual wall. So to do this, we can go up to the View ribbon and then to the Views list and open up Elevation on View A. From here, we'll go ahead and just shrink the work area by going to the Work Area dropdown, selecting by 2 points, and then picking an area that extends over the left grid. Next step, we want to raise these blocks so they sit on at 0 elevation, so we'll select them all. Right-click and hit Move, and then we'll grab the bottom of the block and then just snap up to the grip or the 0'0" grid line. Now that we have this, what we can do is select them all and copy them vertically, 8 inches up and 8 inches over to the right in the positive direction. And you can see here now we have 2 courses. Now from here, what we can do is simply select both of those courses and dictate a number of copies of those, so say 5 of them, and copy them up 1'4" each. And all of a sudden, we have ourselves what looks like the beginnings of a wall. So now that we have our wall basically laid out, we can go ahead and add some bond beams and some end conditions. So we'll put a bond beam in every 4th course, and we're going to start at the first bond beam, and we're going to choose the left side, double click on that block, and we can come down and load up our bond beam setting that we created earlier, and then just, looks like we need to change the block name here. Let's go ahead and change that to bond beam, and let's hit Save As to update our setting, and then we can go ahead and hit Modify, and that's going to change our block for us. Now we can select the rest of the blocks in that row and hit Modify as well as the next row 4 courses up and then the top one. Pretty simple and pretty straightforward. So as you can see, having most of that populated in a safe setting saved us a little bit of time during modeling. So let's go ahead and add some end conditions to the wall here on the left hand side. I'm going to choose these blocks right here on the courses that require a half block, and I'm going to just copy them over 8 inches. You can actually snap to the grid line there. Now you'll see I have some overlap, but we're about to fix that. In fact, let's double click on the top bond beam and let's go ahead to our shape catalog. And in here, we're going to come down and we're going to look for the appropriate block, which is going to be 8x8x8-BB. So once we select that, we can then hit OK. And then we'll come back and we'll change the name to be bond beam half and the design name also to be BBH. Now, if you want to save this away for later, you can go ahead and do that now as well. In fact, I'll do it as well. TS_bond_ half. Oh, forgot the CMU. Let's go ahead and put that in. CMU_ and then hit Save As. There we go. Now let's go ahead and do the same for the regular blocks. I'm going to go ahead and load up the regular block setting that we have previously, and then I'm going to change the Save As name to half instead of full, and then I'm just going to change right here in the shape field the 16 to another 8, so it's 8x8x8, and change the name from regular to half. And then the same thing for the design name, changing it to H. And the reason we're doing this is so that we can make the blocks unique. And that allows us to filter and categorize much more effectively inside of Tekla. So then we'll select the blocks appropriate and then hit Modify. And we have our half blocks there at the end. Now, one thing to notice here is that we have an open end here on our bond beams. And actually, I think we should use a different block. So let's go ahead and load up that bond beam half setting that we have. But let's go ahead and change it. We'll go to the shape catalog, and in the catalog, let's choose the CMU 8x8x8 E1E. So that's open-ended with one end, and hit Modify, and that's going to close it off. Now, if we were doing this on the other side, we're just going to have to rotate the block 180 degrees. There we are. Before proceeding forward, I'm going to show you a little trick, and that'll help us tighten up our grips so they're not just floating out into the middle of other blocks. What we'll want to do is go ahead and select all of the half blocks that we just placed, both bond, beam, and regular. And then once we do, we're going to hit Control P and then zoom into that left side. And then we're going to hold down the Alt key and do a crossing window from left to right down. And you can see it just grabbed those endpoints there for us. Now we can right click and hit Move and then just tidy those up to the end of the block. Now, you don't have to do this, but I like to keep things tidy, and if you do find that you have a lot of grips all over the place, this is one way you can edit many of them at once. Now, before we proceed onward, go ahead and pause the video and then add the end conditions to the other side of the wall. Now that we have our end blocks or our half blocks on either end of the wall, there are two little things I'd like to cover before we end the lesson. First and foremost, we're going to copy this panel over and leave a gap in between. It's pretty simple to do. Just select all the blocks, right-click, hit copy, and then I'm just going to use a common base point. We'll just use the start point of the first course, and we'll come over. I'm going to click snap to the end, and I can see that it's 21 feet 11 and 5/8, so I'm going to key in 22 feet to add a 3/8 inch seam. Now, you may want this or need this to be larger, so just adjust the dimensions appropriately, but the idea here is that it's pretty easy to copy these blocks over, especially when you're in the elevated view, and then we can also go ahead and verify that distance there using the measure tool from the edit ribbon. The one other thing that we are going to address is perhaps we have a return on one or both ends of our overall wall. And we can adjust these pretty easy. It's the same process we've been using this entire lesson, but I'd like to go ahead and quickly demonstrate. Okay, so I'm going to switch back to the 3D view. What I'm going to do is I'm going to select this top half bond, and I'm going to right click and go Move, Special, Rotate. I'm going to pick the start point as the rotation point, and I'm going to change the angle in the dialog to 90 degrees. And I'm going to hit Move. And then I'll interrupt the command, and then I'm just going to align these blocks up using the lower left corner of the half block. So from here, we just need to open up the CMU dialog and go ahead and select a different profile. Let's go ahead and do a whole bond block, but also with a cutout opening on the right-hand side. So if we look in our shape catalog, we can see over here, CMU 8x8x16-BB F1E cut right. And you can see it kind of lines up and continues the bond. So now I can select the other bond half blocks and apply those properties to them as well. And in fact, I'm going to do it to all the blocks, even the regular ones, because it'll help me get my orientation. From here, what we can do is delete the rest of our half blocks and use this one as a starter point up at the top. I'm just going to select it, right click and do copy linear. We're going to copy it down 16 inches, so that's minus 16 in the Z axis, and then we're going to do 5 copies, and then we're going to hit copy. Now all we need to do is just adjust the few that are not actually bond beams. It saves us a couple of steps for having to rotate each block just because they're a different type. But here we have it, and the beginnings of our return. Although it's easy to model this brick by brick like we would in the real world, it does become a bit tedious, and it took us a little bit of time to put in 2 separate segments of an overall wall. The CMU Wall tool, which is covered in our next lesson exclusively, will show us how to expedite that and increase our productivity and efficiency immensely. This concludes Lesson 1, Masonry Tool Basics, Part 1. Please proceed to Lesson 2, Masonry Tool Basics, Part 2.